cup. That is, sample whose viscosity has to be determined. So I have to take it in the cup. And then it has to be placed under the rotating bob. So this is the representation of bobs, that is spindle will be rotating, and this has to be placed under the rotating bob. So the viscous drag that is created by means of the sample due to the rotation of this particular bob or spindles, so causes will be having the torque, and torque is directly proportional to the viscosity. So therefore, depending upon the torque produced by means of the sample on rotating bob, so it displays the viscosity and whose viscosity is to be noted. So like this, the viscosity can be determined at various RPMs, and you can construct the rheogram for this particular suspensions also. So rheogram is flow curve. Rheogram is flow curve. So for to determine the viscosity with Cup and Bob Viscometer, you require large amount of the sample. That is, more sample is required. But that can be overcome by the use of cone and plate viscometer. So here sample is placed on the center of the plate, and it is raised top beneath this particular rotating cone. And here also the viscous drag of the sample causes torque, and torque is directly proportional to the viscosity. So which displaces the viscosity of the sample. So where the viscosity can be noted, and it can be also determined at various RPM, and we can plot the rheogram for this particular suspensions, that is nothing but flow curve. So from the rheogram, we can determine whether it is following plastic flow, pseudoplastic flow, or dilated flow. So the advantage of cone and plate viscometer is with less amount of the sample also we can determine the viscosity of the suspension. Where the disadvantage of the Cup and Bob viscometer is more sample is required, and during the determination of viscosity, plug flow may be achieved, plug flow may be seen. Due to this particular plug flow, it produces the viscosity values with error. And apart from this particular one, it takes more time to clean, and it takes more time to reach equilibrium with the temperature during the determination of viscosity. So this is how we can determine the viscosity of the suspension by the use of two types of multi-point or rotational viscometers. Multi-point or rotational viscometers. And next test is sedimentation parameters. Next test is sedimentation parameters. So in sedimentation parameter, we can determine sedimentation volume, sedimentation rate, degree of flocculation, and redispersibility of the suspension. So what is sedimentation volume? How it can be determined? So what is sedimentation volume and how it can be determined? So the sedimentation volume is represented by means of symbol F. So where it is defined as it is a ratio of volume of sediment to volume of the suspension. Volume of sediment to volume of the suspension. So how to determine the sedimentation volume? So sedimentation volume can be determined by placing the known volume of the suspension in a graduated transparent measuring cylinder. So let us take a 150 ml measuring cylinder. So place 100 ml of the suspension in that particular measuring cylinder and note the sedimentation volume by placing the suspension for 24 hours. So place the volume of sedimentation after 24 hours in the numerator and place the original volume of the suspension, that is 100, in the denominator. You will be getting the sedimentation volume. So the sedimentation volume can be represented by means of F. So when in a physically stable suspension where there is no sedimentation of the particles, the F value will be equivalent to 1. So the F value will be equivalent to 1. So whereas in case of suspensions, there is a sedimentation of particles, the F value will be less than 1. So if F value is less than 1, so it indicates that the volume of sediment is less when compared to the volume of the suspension. So therefore, the system is in flocculated, whenever the F value is equal to 1, the system is in flocculated equilibrium and does not shows will be having the any clear supernated liquid on stand. And sometimes the F value will be less than 1. So in this case, the particles will be settling where volume of sediment is less when compared to the original volume of the suspension. And sometimes we may observe the F value greater than 1. So which indicate that the sediment volume is greater when compared to the originally placed suspension volume. So whenever it indicates that, so whenever the F value is greater than 1, the sedimentation volume is greater than the original volume of the suspension due to the network of flocks that is formed in the suspension, which are very loose and fluffy sediment. So due to this particular loose or fluffy sediment, it crosses the sedimentation volume greater than the original volume of the suspension. In this case, we cannot say that it is not a stable suspension. So due to the formation of loose or due to the formation of fluffy sediment, the value will be greater than 1. The value will be greater than 1. So and next one is sedimentation rate. So sedimentation rate. So here this can be performed by noting the height of the sediment at different time intervals and plotting a curve between time versus will be having the height of sediment. So in the previous case, we are determining the sedimentation volume with respect to aging, that is for 24, 48 or 72 hours. But in case of sedimentation rate, the sediment height has to be noted at different time intervals for half an hour, 1 hour, 1.5 hour, 2, 4, 6, 8 and 12 hours. And we have to plot a graph between time versus height of sedimentation. So those graph which gets parallel to the value f is equal to 1, so it indicates that it is a better suspension. And it also gives about what is the rate of settling of particles with respect to time. So what is the rate of settling of particles? So with respect to time. So this is about the sedimentation volume and sedimentation rate. So similarly, we can also determine degree of flocculation. So where previous method, that is determination of sedimentation, is non-destructive method. So means suspension will not be destroyed. So that we can determine the sedimentation volume and sedimentation rate very easily without disturbing the suspension. And next evaluation test is degree of flocculation. So degree of flocculation is represented by means of beta. Degree of flocculation is represented by means of beta. So where it is the sedimentation volume in flocculated suspension to sedimentation volume in deflocculated suspension. So here we have to observe that flocculated suspension is one where flocks of the particles can be seen. In deflocculated suspension, we cannot see the flocks of the particles. So if at all the suspension formulated is a flocculated suspension, so you have to determine the sedimentation volume of flocculated suspension, and then you have to determine the sedimentation volume of deflocculated suspension also. So the ratio of this particular two gives degree of flocculation. Degree of flocculation. That is beta is equal to F by F alpha, where F is given by means of VU by V naught. F alpha is also given by means of V alpha by V naught. When you are taking both the suspensions in similar volumes, so V naught will be becoming the same. So therefore, beta becomes V naught divided by V alpha. So V naught is the volume of sediment in flocculated suspension, and V alpha is volume of sediment in deflocculated suspension. So in this case, the suspension has to be destroyed. So since the flocculated suspension is converted into deflocculated, or deflocculated suspension is converted into flocculated by the addition of flocculating agents. So the minimum value of this particular beta will be equivalent to 1 whenever the sedimentation volume in both the suspensions will be equal. So whenever the sedimentation volume in both the suspensions are equal, so then in that particular suspension, we can say that the sedimentation is not there. So by because means both the suspension does not possess any sedimentation. And next one is redispersibility. So the formation of sediment cannot be removed from a suspension. Of course, if you are formulating the suspension by taking all the precautions to reduce the settling of the particles, in every suspension that is formulated, there are the chances for settling of the particles. Even if the particles are settled, they are easy to redisperse upon moderate shaking. So therefore, to see that whether the settled particles distribute uniformly or not through moderate shaking, we have to perform the redispersibility test. How to perform the redispersibility test? So you have to shake the emulsion by placing in the bottle, and you have to see that particles are well distributed or not. So it is difficult to shake uniformly every time, so you can use a mechanical or reciprocating shaker. This reciprocating shaker should be used in such a way that it simulates the motion of human hand shaking. So means that, so how we are shaking the bottle, so how to shake the shaker in such a way that it should also shake in the same way. So by the use of this particular mechanical shaker, you can shake the suspension, and you can see that what is the time taken for redispersibility. If redispersibility takes place very quickly, it is considered to be stable suspension. If redispersibility of the particles does not take place even after shaking for more time, it indicates that the suspension is not physically stable. It indicates that the suspension is not physically stable. So this is how we can check the redispersibility of the suspension. So this redispersibility also gives information about sedimentation only. So whenever cake formation is there due to sedimentation, redispersibility will not take place. Whenever there is absence of cake forming, so the particles will be redispersed upon moderate shaking, either by the use of human hand or mechanical shaker that simulates the motion of human hand. So these are the various parameters that are related to sedimentation that can be determined as a part of evaluation of physical stability of the suspension. As a part of evaluation of physical stability of the suspension. And the next test is particle size. Particle size. So the simple method for the determination of particle size of the suspension is microscopic method. So where in this particular method, we can take the microscope and we can fix the eyepiece micrometer in the eyepiece of the microscope, and stage micrometer has to be placed on the stage of the microscope. By placing the stage micrometer, the eyepiece micrometer is calibrated. So after which the stage micrometer has to be removed. And we have to place a drop of diluted suspension on the glass slide, and we have to focus the 100 particles over the eyepiece micrometer. And you have to note the size and number of particles. And from this, we can plot the cumulative frequency distribution curve, and the average particle size can be determined. So whenever the microscopic method is a tedious process, we can go for counter operators. So this, by the use of this particular operators, by placing the suspension in this particular operators, it determines the number of particles and size of the particles. Determines the number of particles and size of the particles. For what purpose we have to determine the particle size? So whenever the particle size is increasing, it indicates that in the suspension, there are the chances for flocculation or followed by formation of clumps in the suspension. Whenever there is a formation of clumps or aggregates in the suspension which are not easy to redisperse, they show large particle size when you are determining the particle size in the suspension. So therefore, whenever you are observing clusters or large size of the particles, it indicates that so the suspension is not stable. So whenever the uniform size of particles are there throughout the suspension, it indicates that the suspension is physically stable. So increase in particle size when compared to the reference standard may lead to lumps or caking in the suspension, so which automatically is not a physically stable suspension. Is not a physically stable suspension. And next one is zeta potential. Mainly this is important for flocculated suspension. So the potential carried by means of the particles in the suspension to minimize the cake formation is nothing but zeta potential. So this zeta potential gives the information about stability of the suspension, and the zeta potential of a suspension that is prepared can be determined by the use of microelectrophoresis operators. So this is the representation of microelectrophoresis operators, and apart from this particular operators, we can also use zeta plus instruments for the determination of zeta potential of the prepared suspension. So the determination of zeta potential will be helpful for assessing the stability of the suspension. So here to determine the zeta potential by the use of two operators, that is microelectrophoresis or zeta plus operators. So approximately how to place 1 ml of the sample into a cuvette, and you have to into a plastic cuvette by using pipette, and you have to dilute that particular sample with water, that is distilled water, and you have to measure the zeta potential at 25 degrees centigrade and at a refractive index of 1.33 on 0th day, 7th day, 14th day, 21st day, and 28th day after the formulation. So already we have discussed that a flocculation suspension should possess zeta potential value of -20 millivolts to +20 millivolts. So whenever this zeta potential is possessed by means of the suspension, so the attracting of particles in the suspension can be minimized, and hence the cake formation in the suspension can be minimized, and it contributes to the physical stability of the suspension. So this is how the zeta potential of the suspension can be determined. And next one is, so you have to evaluate the effect of temperature on stability of the suspension. Effect of temperature on physical stability of the suspension. So the effect of temperature on physical stability of the suspension can be done by means of freeze-thaw cycling. Freeze-thaw cycling. So means that the suspension has to be kept in the freezer for 18 hours and at room temperature, that is between 26 to 30 degrees centigrade for 4 to 6 hours. So like this, you have to keep for 10 cycles. So one cycle completes whenever you will be keeping in the freezer for 18 hours and at room temperature for 4 to 6 hours. So like this, you have to keep the sample for 10 cycles, and after exposing to 10 cycles, you have to evaluate the density, sedimentation, viscosity of that particular suspension. So the physical parameters has to be evaluated, like appearance, color, odor, taste, density, pH, viscosity, etc. has to be evaluated. Any change in this particular physical parameters after exposing to freezing condition or temperature condition, that is 26 to 30 degrees centigrade. So it indicates the physical instability of the suspension. When you are exposing to this particular temperature, when there is no change in the physical parameters, like no change in appearance, color, odor, taste, etc., it indicates that the suspension can withstand the freezer temperature and it will be stable at 26 to 30 degrees centigrade. 26 to 36 degrees centigrade. So this mode of evaluation will be helpful for determining the effect of temperature on physical stability of the suspension. A physically unstable suspension cannot withstand this particular temperatures when you are exposing to freeze-thaw cycles. So freeze-thaw cycles. So a stable suspension which withstands this particular freezing temperature and thawing temperature, so will be responsible for showing it will be responsible for it does not shows any variation in the physical parameters, right? So this is the freeze-thaw cycle. So freeze indicates refrigerator temperature, thaw indicates so room temperature or greater than room temperature, so that the name is considered as freeze-thaw cycle. Freeze-thaw cycle. And last unofficial test for suspension is dissolution testing. So here, what is the purpose of performing the dissolution testing means? So since suspension consists of insoluble solid drug particles, so which needs to converts into solution form before crossing the biological membrane. For that particular purposes, we can also perform in vitro dissolution studies for this particular suspensions. So the in vitro dissolution studies can be carried out by the use of USP type 2 operators. USP type 2 operators. So the USP type 2 operators is rotating paddle type of operators. Rotating paddle type of operators. So let us see, the USP type 2 operators consists of 1 liter beaker, and this beaker is dipped in a water bath to maintain the temperature 37 plus or minus 0.5 degrees during the dissolution. And it consists of a paddle which will be rotating during the dissolution testing, and the paddle is attached to the rotating motor with the help of shaft, and this paddle and the shaft will be made up of the stainless steel material of 316 grade, and the distance between the end of the paddle and hemispherical bottom of the vessel is approximately 2 centimeters. 2 centimeters. So coming to how to perform the test. How to perform the test. So first of all, USP type 2 operators, that is rotating paddle type of operators, has to be clean and it has to be calibrated. So means in paddle type of operators, paddle will be rotating. We have to see that whether the rotations are made as per the setting parameters or not. That means if you are setting 25 per minute, it will be rotating 25 revolutions per minute or not. And you have to see that whether the temperature is maintained properly to 37 plus or minus 0.5 degrees or not. So, and you have to set that whether the time that is set to the dissolution operators is displaying in an appropriate manner or not. So after setting all these particular things, what we have to do is, so the external water bath has to be filled with water up to the level. So not this you have to dip in the external water bath. So the water bath has to be filled with water up to the level. And you have to switch on the heater so that it heats to 37.5 to 37.5 plus or minus 1 degree centigrade. 1 degree centigrade. So after heating, so I have to place the 1 liter beaker and you have to place 900 ml of appropriate dissolution medium. So this dissolution medium appropriate indicates it depends upon the type of drug present in the suspension. For each and every drug in the monograph will be having the dissolution medium will be there. You can use that particular dissolution medium to carry out or to perform the dissolution. Right. So after placing the 900 ml of the dissolution medium, so I have to allow the dissolution medium to reach 37 plus or minus 0.5 degrees centigrade. And you have to allow the paddle to rotate at 25 rpm. Now the apparatus is ready in order to place the dosage. What we have to do? So since suspension is a liquid dosage form, we cannot introduce as such into the beaker. So I have to place 5 ml of the suspension in a pouch. So pouch usually will be made up of with Durapore membrane. So that is made up of polyvinyl fluoride. So which is prepared by means of millipore company. So into that particular pouch, you can place a 5 ml of the suspension. So and you have to tie like a tea bag pouch and you have to submerge into the dissolution medium. And you can perform the dissolution. So periodically you can withdraw the samples and you can replace with fresh volume of the dissolution medium that is maintained under similar conditions. So here the purpose of replacing is in order to maintain sink condition during the dissolution studies. So always in vitro dissolution studies ought to be performed under sink condition. So since in vivo dissolution takes place under sink condition only. So after taking the samples from the analysis of the samples, so I have to analyze the sample by means of appropriate analytical method and you have to determine the amount of drug that is present, and by this way the amount of drug that converts into solution form per unit time can be determined by the use of dissolution testing. So of course this is also not official, but we'll be using the official operators, that is USP type 2 operators. So this is a test which is still under process for development for the suspension. But to know the drug release from the suspension, you can perform this particular dissolution testing also. So these are the various unofficial tests that are to be performed for suspensions. So next coming to, so what are the official tests we have to perform as per IP? So IP specifies that for biphasic liquid dosage forms like suspension, so I have to perform 2 tests. So they are uniformity of content and uniformity of volume. So the main purpose of performing the uniformity of content test is to know whether the active ingredient that is present in the formulation is uniform in all containers or not. That means the drug present in the all containers is uniform or not. We have to perform the uniformity of content test. So on the label of each and every formulation, it will be specified that each family of the suspension contains so much mg of the drug. So whether this particular mg of drug that is present in the all containers is uniform or not, so I have to perform this particular uniformity of content test. And one more important parameter that needs to be tested is uniformity of volume. So here to ascertain that whether the volume of the preparation in all containers is uniform or not, we have to perform the uniformity of volume test. So generally the biphasic liquid dosage forms are packed in the containers of appropriate volume like 50 ml, 25 ml, etc. So whether the volume of the preparation that is present in all containers is uniform or not, to know this, will be performing the uniformity of volume test. So this is the main aim of performing the uniformity of content and uniformity of volume test. So let us see how to perform the uniformity of content test. To perform the uniformity of content test, so we have to select 10 containers randomly. So from the batch of suspension that is prepared in the industry, so I have to select 10 containers randomly. So after the selection of 10 containers, what you have to do is, so first take the first container. First take the first container. So perform assay according to the procedure that is specified in the IP. Let us assume that you are performing for amoxicillin suspension. So amoxicillin monograph will be there in the IP. Take that particular monograph, note the assay procedure, perform the assay. So after performing the assay, calculate the amount of amoxicillin present in definite volume of the suspension, that is PAML of the suspension, and convert into percentage. So the amount that is obtained divided by label claim into 100 gives percentage. Suppose if in the label claim each PAML contains 500 mg of amoxicillin, the label claim becomes 500. You can analyze చేసిన 400 వచ్చింది అనుకోండి, 400 divided by 500 into 100 gives percentage. So that for the same procedure you have to repeat for remaining 9 containers. So after repeating for 9 containers, totally you will be getting the percentage values of all 10 containers. So if all obtained values are between 85 to 115 percentage, after performing the assay for 10 containers, if all the obtained values are between 85 to 115 percentage, it complies with uniformity of content test as per IP. So means it passes the test as per Indian Pharmacopoeia. If all containers values are between 85 to 115 percentage, right? And it fails to comply. That means that it does not passes the uniformity of content test if more than one is less than 85% or greater than 115%, or if any value is less than 75% or greater than 125%. Right? Out of 10 that are selected for determining the uniformity of content, if any value is less than 75% or greater than 125%, or more than one is less than 85 or greater than 115%, it fails to comply with the test. It fails to comply with the test. So means that if all are within the limits, it passes. If more than one is outside the limit, it fails. If anyone is less than 75 or 125, it fails to comply with uniformity of content test. So what about if 9 out of 10 are within the limits? What about if 9 out of 10 are within the limits? If only one individual is less than 85% and greater than 115%, but that is within the 75 to 125%, what we have to do? So we have to repeat the uniformity of content test. So I have to repeat the uniformity of content test. So uniformity of content test has to be repeated with 20 containers. 20 containers to repeat here. So after repeating, totally it will be becoming 30. So in the first, you will be performing with 10 containers. In the second stage, in the repetition process, you will be performing with 20 containers. Right? So out of 30, not more than 3 out of 30 should be less than 85 and greater than 115%. And not more than one is outside the limit of 75 to 125% of the average value. So if this is the criteria, it complies with uniformity of content test. So if more than 3 or less than 85 or greater than 115, if more than one is less than 75 or greater than 125%, it fails to comply with uniformity of content test. It fails to comply with uniformity of content test. Right? So this is how to perform the uniformity of content test and whether the performed product is passing the uniformity of content test as per Indian Pharmacopoeia limits or not. Indian Pharmacopoeia limits or not. And next, after the uniformity of content test, so the other official test as per Indian Pharmacopoeia is uniformity of volume. Uniformity of volume. So the main aim of this particular test is we have to determine the volume of contents of 10 containers. Volume of contents of 10 containers. So means to perform the uniformity of volume test also, we have to take 10 containers randomly from the batch. Right? So sampling in this quality, we have to take 10 containers at a random. And you have to determine the individual volume and average net volume. So how to determine the individual volume and average net volume? So among the 10 containers that are selected for uniformity of volume, take first container. Take first container, open the container, and transfer the entire contents into measuring cylinder and note the volume. So this use will be having the individual volume. So likewise, you repeat for remaining 9 containers. After determining for 10 containers, add all the volumes, divide by 10, you will be getting the average volume. So the average net volume of the contents of 10 container should be same as labeled amount. Suppose make 100 ml on the label claim. So meeru anni determine chesi 10 containers individual volume, add chesi, divide by 10 chesi, make average also. The average should be same as 100 ml. And the net volume of the contents in any single container should not deviate plus or minus 9% or plus or minus 4.5% or plus or minus 3% depending upon the volume of the preparation in the container. If the volume of the preparation in the container is 50 ml or less, so the percentage deviation acceptable for net volume of single container is plus or minus 9%. That is, the single container value should not be less than 91% and it should not be more than 109%. So the volume of the preparation in the container is more than 50 ml but less than 200 ml. The percentage deviation acceptable is plus or minus 4.5%. That is, the net volume of contents of any single container should not be less than 95.5% and it should not be greater than 104.5%. So whenever the preparation volume is more than 50 ml but less than 200 ml, and whenever the preparation volume is greater than 200 ml but less than 300 ml, the percentage deviation acceptable for net volume of single container is plus or minus 3%. That is, the net volume of any single container should not be less than 97% and it should not be more than 103%. If this criteria is not met, and pass you have to repeat for additional 10 containers. And in the repetition process, again, you have to select 10 containers and you have to determine the average volume and individual volumes. And you have to see that average volume is same as labeled volume and not more than 1 out of 20. And the initial chase in 10, next chase in 10, it will be becoming 20. So not more than 1 out of 20 can deviate by means of the percentage deviation that is specified above depending upon the volume of the container. So if it is 50 ml plus or minus 9%. So if it is more than 50 ml but less than 200 ml, so plus or minus 4.5% is acceptable. So if it is more than 200 ml, plus or minus will be having the plus or minus 3% is acceptable. So if in the repetition process and mali 10th chase and repeat chesinapudu kuda, if more than 1 is deviating, it fails to comply with uniformity of volume test. So whenever the uniformity of volume test is failing, it indicates that the volume of preparation in all containers is not uniform. Whenever uniformity of content is failing, so it indicates that the active ingredient content in all containers is not uniform. So the active ingredient content is not uniform. So this is how we can perform the uniformity of content and uniformity of volume test, right? So this completes the what are the various evaluation tests to be performed for the first biphasic liquid dosage forms for suspensions. So next we will move on to the emulsions. So emulsions are also biphasic liquid dosage forms that contains two immiscible liquids, that is water and will be having the oil. So since they are immiscible with one another, so they can be made miscible with the help of third substance known as emulsifying agent. For the emulsion also, so after the formulation is over, so what we have to do is we have to perform the quality control test or evaluation test. So in order to assess the, in order to confirm the quality of the prepared emulsions. So for that, the evaluation test to be performed for the emulsions are, So like suspensions, we can also perform appearance, color, odor, and taste of the orally administered emulsions. So orally administered emulsions. So the appearance is uniform or not, whether the color, odor, and taste are same as the reference standard or not has to be checked, because any changes in this particular qualities indicate that so the emulsion is not physically stable. So after that, you can determine the viscosity of the emulsion. So since emulsion is also a non-Newtonian system, so the viscosity of the emulsions can be determined by the use of will be having the multi-point or rotational viscometer, either cup and bob type viscometer or cone and plate type of viscometer. So this viscometer, when you are placing the sample in the viscometer, so it displays the viscosity value, so which can also be determined at various RPMs, so that you can plot a rheogram or flow curve for this particular viscosities of the emulsions. Viscosities of the emulsion. So mainly viscosity of the emulsion also will be helpful for determining whether the emulsion is stable or not. So if the emulsion viscosity is high, automatically the coalescence, flocculation can be prevented, and it also can be prevented for creaming. So whenever the emulsion possesses viscosity without any alteration, so it will be responsible for minimizing the coalescence, flocculation, and followed by creaming in the emulsions. Creaming in the emulsion. So one more parameter like particle size in the suspension. In the emulsion, you need to determine the size of the globules. You need to determine the size of the globules. So such a test is called as globule size analysis test. So how to determine the globule size means in emulsions, the globule size can be determined by the use of microscopic method. So for this, the eyepiece micrometer has to be calibrated with stage micrometer. So after calibration is over, you have to place the drop of diluted emulsion on the glass slides. So focus at least 100 representative fields and count the size of the globules. So the change in the size of the globules will be helpful for assessing the emulsion is stable or not. Any increase in the size of the dispersed phase indicates it is a flocculation is taking place in the emulsion. Or any change in the size of the emulsified globules indicate that coalescence in the emulsion has been taken place. Apart from, so you can also determine will be having the electrical conductivity of the prepared emulsion. So like from this particular test, what we can do is we can identify the type of emulsion, like whether it is a O by W type of emulsion or W by O type of emulsion, and also indicates in O by W type of emulsion whether the emulsion is stable or not. When it is stable, so since water is a continuous phase, it conducts electricity. So when it is not stable, so since water will not be the continuous phase, so it fails to conduct the electricity. And in case of micro emulsion, when you are exposing this particular micro emulsion to light, so generally what will be happening means this emulsion will be reflecting this particular light also. So therefore, you can perform the light reflection test. So means that you have to focus a beam of light on the emulsions. So can focus a beam of light on the emulsions, and you have to observe a reflection of the light on the emulsion. From this, the type of the emulsion can be determined. So from this, the type of the emulsion can be determined. And last test is phase separation. Last unofficial test is phase separation. So generally in emulsion, the phase separation should not be there. So that is uniform presence of one phase in the other phase should be there, so that it appears as a stable emulsion to the naked. So that you have to perform whether the phase separation is there in the emulsion. So for this, what we have to do is how to observe the emulsion under the microscope, and you have to observe whether this particular oil is dispersed as a globules in water, or water is dispersed as a globules in the oil or not. So whenever this particular dispersion is there without any separation of water and oil, oil and water, so it indicates that the emulsion is stable without any phase separation. So these are the various unofficial tests that gives about the quality of the emulsion. That is viscosity, globule size, electrical conductivity, light reflection, and phase separation. And apart from this particular one, so the shelf life of the emulsion can be assessed, or stability of the emulsion can be assessed very quickly by accelerated stability analysis. That in order to evaluate the stability of the emulsions very quickly, so how to expose the emulsion to stress conditions. So what are the various stress conditions that the emulsion has to be exposed means? So the emulsion has to be exposed to the aging and temperature. So generally a stable emulsion should not show any signs of the separation when you are exposing to different types of temperature at different time periods, like 60 to 90 days for 45 degrees centigrade or for 50 degrees centigrade. So and 5 to 6 months at 37 degrees centigrade and 12 to 18 months at room temperature. So either of this particular temperature conditions has to be selected. Either 45 to 50 degrees centigrade select chestunte ganaka, so it is for 2 to 3 months. So if you are selecting at 37 degrees, it is 5 to 6 months. So if it is at room temperature, you have to select for 12 to 18 months. Or 1 month storage at 4 degrees centigrade or 2 or 3 freeze-thaw cycles between -20 and 25 degrees centigrade. Or 6 or 8 heating cooling cycles between refrigerated temperature and 45 degrees centigrade. Storage at heat temperature should not be less than 48 hours. So therefore, the effect of temperature on the physical stability of the emulsion can be quickly assessed by means of exposing to this particular temperature conditions. Likewise, so if the emulsion is free from creaming or not, can be assessed by means of exposing the emulsion to centrifugation process. So if you are exposing the sample of emulsion to centrifugation force at 2000 to 3000 rpm at room temperature, so the emulsion should not show any serious deterioration. So means that, so it should not take upward creaming or followed by downward creaming. So if at all upward creaming is there or downward creaming is there, when you are exposing to centrifugation process at 2000 to 3000 rpm, automatically it indicates that so the emulsion is not physically stable. When exposed to temperature, when there are the changes in the physical parameters, so it indicates that the emulsion is not physically stable. And next one is, so hesitation. So emulsion should not adversely affected by means of hesitation process for 24 to 48 hours on a reciprocating shaker. So the shaking time period is so approximately 60 cycles per minute at room temperature and 45 degrees centigrade. So means that when you are exposing to this particular shaking process for 24 to 48 hours at room temperature and 45 degrees centigrade, so there should be no change in the viscosity, no change in the globule size, no change in the light reflection, no phase separation, and no electrical conductivity change should not be occurred. So during the above stress condition exposure to the emulsion, so we have to evaluate the physical parameters like viscosity, globule size, electrical conductivity, light reflection, and phase separation. So if these are not changing, it indicates that the emulsion is physically stable. So if these parameters are not changing upon exposing to various types of stresses condition, so automatically the emulsion is not stable. The emulsion is not stable. These are the unofficial tests to be performed for emulsions to evaluate the quality of the emulsion. So where IP specifies official evaluation test, that is Indian Pharmacopoeia specifies official evaluation test. So they are uniformity of content and uniformity of volume. So let us see how the uniformity of content has to be done. So the uniformity of content test is performed in order to determine whether the content of active ingredient present in all containers is uniform for emulsions or not. So for this, you have to select 10 containers randomly, perform the assay and calculate the percentage. So if all the values are between 85 to 115%, it passes the uniformity of content test as per Indian Pharmacopoeia. So if more than one value is less than 85% or greater than 115%, or if one value is less than 75 or greater than 125%, it fails to comply with the test. So if one value is greater than less than 85 or greater than 115, but it is within the limits of 75 to 125%, it passes the uniformity. You have to repeat the test. That is, you have to repeat again the 20 containers. So totally in repetition process and in the first test, you will be having 30 containers will be there. So out of 30 in the repetition process, so if 27 out of 30 are within the limits, it passes the test. If 27 out of 30 are within the limits, it passes the test. So if more than 3 are deviating, that is 4 is deviating or 2 are less than 75 to 125%, it fails to comply with uniformity of content test. So after whenever the uniformity of content test is passed by means of the emulsion, it indicates that the active ingredient that is present in all the containers is uniform. So whenever it is not uniform, so whenever it is failing, it indicates that it is ununiform in all containers. Ununiform in all containers. And last one is uniformity of volume test. Like suspensions for emulsions also, so since it is a liquid dosage form which is packed in the bottles, both will be having the definite volume. So to know that whether the volume of preparation in all containers is uniform or not, will be performing the uniformity of content test. To perform this particular test, we have to select 10 containers randomly. So after that, you have to determine volume of the preparation that is present in individual container and average. So you have to transfer into measuring cylinder, measure the individual volume and calculate the average volume. So the average volume should be same as labeled volume, and the net volume of contents of any single container should not deviate by plus or minus 9% or 4.5% or 3% depending upon the volume of preparation. So if the volume of the preparation is less than 50 ml, the percentage deviation acceptable is plus or minus 9%. Means the net volume of contents of any single container should not be less than 91% and it should not be more than 109%. So if it is more than 50 ml but not more than 200 ml, so the percentage deviation acceptable is plus or minus 4.5%. Plus or minus 4.5%. That is, the net volume of the contents in any single container should not be less than 95% and it should not be greater than 104.5%. So if it is more than 200 ml, so plus or minus 3% deviation is acceptable. Plus or minus 3% deviation is acceptable. That is, the individual volume of any container should not be less than 97% and it should not be more than, will be having the 103%. So if this requirement is not met, అంటే ఇక్కడ పాస్ అవ్వకపోతే మళ్ళీ 10 కంటైనర్స్ లో రిపీట్ చేయాలి. సో రిపీట్ చేసినప్పుడు ఏంటి అంటే మళ్ళీ 10 కంటైనర్స్ లో రిపీట్ చేసినప్పుడు సో నాట్ మోర్ దాన్ 1, that is 19 out of 20 should be within the limits and one can deviate by means of the limits specified in the above. So limits specified in the above. So these are the official evaluation tests to be performed for the emulsions, that is uniformity of content and uniformity of volume. Unofficial or viscosity, phase separation, electrical conductivity, light reflection can be performed. So these are the different evaluation tests to be performed for biphasic liquid dosage forms, that is for suspensions as well as for emulsions, both as per official pharmacopoeia as well as unofficial tests to ascertain the quality and functionality of the product. To ascertain the quality and functionality of the product. So with this, the concepts of biphasic liquid dosage form, suspensions and emulsions, and evaluation test, how to perform with various things and all is completed. So now the session is open for questions on today's part, or if you are having doubt in any of the previous 2 sessions, so you can ask now. So now the discussion on the evaluation test for suspensions and emulsions is completed. Please once again explain the uniformity of content test of suspension. Right. So this is mainly performed to know that whether the labeled amount of the drug that is present in all the containers is uniform or not. And gain cheyali ante man any containers teeskoni test chesthe the preparation will be useless. So I have to take a sample from the bulk, that is 10 containers teeskoni perform the assay. So assay ante determination of drug content in that particular preparation. So if all the containers or all the values obtained assay chesin tarvata you determine the amount, calculate the percentage. If all the values of the 10 containers are between 85 to 115%, it passes the test. So whenever it passes the uniformity of content test, so it indicates that the active ingredient in all containers is uniform. In all containers is uniform. Whenever it fails, it indicates that so the active ingredient in all containers is not uniform. So the active ingredient in all containers is not uniform. Dissolution testing. So since in suspensions insoluble drug will be present, so the insoluble drug has to convert into solution form. So to know how much amount of the drug that converts into solution form, we can perform the dissolution test. So a dissolution test చేయాలంటే the liquid dosage form కాబట్టి, so how to pour 5 ml of the suspension in a Durapore membrane, right? So the tea bag fashion, tea bag type lo tie chesi, you can submerge in the dissolution medium to assess the drug release in the dissolution studies. 5 minutes ki konta sample తీసి you can assess how much amount of the drug is converting into solution form. So like this you have to repeat, you can perform up to half an hour. మీరు sample తీసినప్పుడు so equal volume of the sample has to be replaced with equal volume of the fresh dissolution medium has to be replaced. So ఎందుకంటే to maintain the sink condition during the dissolution, మన సింక్ లో బ్లాకేజ్ లేకుండా ఉంటే ఎలా ఫ్లో అయ్యిందో drug release కూడా, if at all it is maintained at a low concentration, it will be released uniformly, right? So any more questions? Yeah, so freeze-thaw cycling. So here this freeze-thaw cycling, as the name itself indicate that freeze is low temperature and thaw is room temperature or greater than room temperature. Room temperature or greater than room temperature, right? So here this test is mainly done for to evaluate the effect of temperature on stability of this emulsion or suspension, right? So here what will be happening means, if you are subjecting to freezing condition, the effect of freezing conditions on the stability of the emulsion suspension can be determined. For exposing to room temperature or extreme high temperature, the effect of temperature on stability can be determined. So sometimes a stable suspension can withstand this particular cycles. A unstable suspension cannot withstand this particular cycles. So means when you are exposing to this particular temperature condition, either the appearance, color, odor, viscosity, density, etc. may change. Change in this particular parameter after exposing indicates will be having the suspension is not physically stable. So flocculation. So flocculation means aggregation of particles. In flocculated suspension, we may see this particular aggregates, right? This can be achieved by the use of some electrolytes as flocculating agents. So due to the formation of floccules, what will be happening means low compact sediment will be formed. So this sediment can be easy to redispersed upon moderate shake. So if floccules is not there, there are the chances for cake to form in the suspension. If cake is formed in the suspension, it is not easy to redisperse. Whenever the suspension is not easy to redisperse, the drug settles at the bottom, so that whenever the patient is taking the suspension, he may not get the uniform dose of the drug. Explain flocculation method. So what is pseudoplastic flow? So what is pseudoplastic flow, right? So this is the flow exhibits by means of the suspension. So mainly flocculated suspensions exhibits plastic flow, and deflocculated suspension exhibits will be having the pseudoplastic flow. So a plastic flow ante entante manaki flow, when we are applying some sort of stress, flow will not be starting. At one point the flow will be starting, but in deflocculated suspension this flow will be starting from starting point itself, but it will be not directly proportional. So for deflocculated systems, with increase in the viscosity, with increase in the shear rate, the viscosity will be decreasing, and therefore they are known as shear thinning systems also. So it is a flow. So next question is sedimentation volume. So sedimentation volume is represented by means of F, where it is the volume of sediment to volume of suspension. F value nearer ga 1 unte, the suspension is more stable. Whenever it is approaching to 0, the suspension is physically unstable. Next, advantages of Cup and Bob Viscometer. So for determination of viscometer, for determination of viscosity, 2 types of viscometers will be available. So Cup and Bob Viscometer lo aithe kanaka ekku sample kavali, but with the help of both viscometers we can determine the viscosity. It takes more time to clean, and with Cup and Bob Viscometer we can experience the plug flow, so that there are errors in showing the viscosity values. So flocculation methods are determination of sedimentation volume, determination of degree of flocculation, and determination of redispersibility of the suspension. Right? So hope I have cleared the doubts that are raised by means of the participants. Okay. Any more questions from the audience?
Students, any questions?
Explain zeta potential. It is a very good question. So zeta potential is mainly required for the flocculated and deflocculated suspension. So the maintenance of this potential will be decreasing the approaching of particles. Whenever the approaching of particles is decreasing, automatically the settling of particles in the suspension can be settled. So whenever settling is decreased, automatically the sedimentation will be decreased. Whenever the sedimentation is decreased, the suspension will be more stable. So sedimentation rate. So it is the height of sediment formed at different time intervals, like 5 minutes, 15 minutes, 20 minutes, 25, 30, 45. If you are noting with respect to time, that is called as sedimentation rate. Degree of flocculation is represented by means of beta. Is a ratio of volume of sediment in flocculated to deflocculated suspension. Whenever this volume is equal to 1, it indicates that the suspension is physically stable. In that particular suspension, there is no sedimentation. So one question is degree of flocculation, and another question is sedimentation rate, and another one is zeta potential. So I hope it is clear for you. Any more questions?
Yes, sir. Shall we close the session, sir? There are.
Okay, okay, sir.
Okay.
Sir, am I audible?
Yeah, sure, sir.
Okay, okay. Somebody they are posting it is not audible.
I think that is a earlier message, sir.
Okay, okay. Thank you, sir.
Thank you, sir. Thank you, students.
Thank you. Sorry for the interruption, sir. Due to network problem, I am unable to connect for 15 minutes.
No problem.
And after that, I have taken another system to connect. Another network, not system.
Okay, sir.
Okay, thank you, sir.
Thank you, sir. Thank you very much, sir.